All right, so today we're going to look at a couple of examples of using trig ratios, learning how to set it up, and then we'll look at using them to solve problems involving right triangles. So first and foremost here, let's look at the right triangle we have. So it's a 3, 4, 5 triangle, so we know it's definitely a right triangle. If we didn't know to be sure, we could do 3 squared plus 4 squared, and it should equal 5 squared, which it does. So inside this triangle, we have our right triangle, or right angle, and we have two other angles, alpha and theta. So alpha and theta. Could call them X and Y, could call them blue blob and kika, whatever you want. As long as you have some kind of variable form. So in regards to this, we're going to set up the trigonometric ratios, the three trigonometric ratios for each angle, so we can see the kind of relationships that we have between them. Well, to start this off, we'll do alpha first. And because we're doing alpha, let's label the sides in relation to alpha. So in relation to alpha, I then see that, hey, this is still my hypotenuse no matter what. So I'm going to label this with an H for hypotenuse. And then from alpha, I know that the 3 is not touching it, so it's opposite of it, so an O. And then that means that this 4 over here must be the adjacent side, or A. So I have the hypotenuse, the opposite side, and I have the adjacent side. Okay, why is it important to label these? Because in order to find sine, cosine, and tangent, we must know the opposite side, the adjacent side, and the hypotenuse. By labeling it, we can clearly see it no matter what. And this is in regards to alpha, not theta. When we get to theta, we'll have to change it a little bit. So in regards to alpha, what is sine? Well, sine, if you remember that SOHCAHTOA thing I showed you before, as I said, that's the most common way that people remember this. Sine is opposite divided by hypotenuse. So what side is opposite? Well, because we labeled our sides already in regards to alpha, we know that the opposite side is 3 and the hypotenuse is 5. So we automatically know what sine is. It's 3/5. Awesome. So for alpha, the sine function would give us 3/5 or 0.6. Okay, let's look at cosine. Well, cosine is adjacent divided by hypotenuse. So in that regards then, our adjacent side would be 4, and we would divide by the hypotenuse 5. Well, that's excellent. We know then that the cosine of alpha would be 4/5 or 0.8 if we use the cosine function on alpha. Okay, what about the tangent function? Well, let's see. So tangent of alpha would give us the opposite divided by the adjacent side. So opposite divided by adjacent, the opposite side is 3, and the adjacent side is 4. So tangent would be 3/4 or 0.75. That's what we would get for the tangent function if we put in alpha. That's great. Well, because we know these, we can use any one of these pieces of information to find alpha. And we'll talk about finding angles using this in a couple of videos. But first of all, let's look at theta though. Let's see what the relationship is to alpha and theta, because they're going to be a little different from one another. Well, first of all, let's relabel our sides, because we're looking at it in regards to theta now. So that's no longer going to be opposite, and that's no longer going to be adjacent. However, 5 is still the hypotenuse, right? Yes, it is. So let's do this for theta. So in regards to theta, the opposite side would be the side that's not touching it. So that would be the 4. And also see how it's opposite of it? That means that the 3 must be our adjacent side. Okay? So in that regards, what is sine? Sine is opposite over hypotenuse, so the opposite side would be 4, and the hypotenuse would still be 5. So that's what sine of theta is. Hey, isn't that what we got for cosine over here? Huh. Okay, let's move on. Let's look at cosine here. Cosine of theta. Cosine is the adjacent divided by hypotenuse. So cosine would be 3/5. Okay. Well, isn't that what we got over here for sine of alpha? It is. Which makes sense because these two angles are complementary of one another. So when we flip sine and cosine going to the other angle, you should get the exact same. So sine of theta would equal cosine of alpha. Cosine of theta would equal sine of alpha. This isn't anything that you have to actually know. It's just something to kind of recognize because it's kind of cool to see, and two, it may help you in the future figure out things more quicker if you already understand that relationship. Okay, well, let's look at tangent of theta though. So tangent is equal to the opposite divided by the adjacent. Well, the opposite side of theta would be 4, and the adjacent side would be 3. That looks similar to tan of alpha, but it's the reciprocal of it. But didn't we say the reciprocal was cotangent? We did. So, as you can see, there is a relationship between alpha and theta based on the sides. So if you know theta and you know sine of theta, you automatically know what cosine of alpha is. If you know cosine of theta, you automatically know what sine of alpha is. And if you know tangent of theta, you can flip it and get tangent of alpha. So those are just cool relationships. But the most important part of this is practicing labeling your sides so that you can set these ratios up correctly. Okay? So that is trigonometric ratios, and we will look at how to use these in order to find missing sides and find out what is the actual measurement of that angle. And we'll do this using those buttons we see on the calculator that say sin, cos, and tan. Sine, cosine, and tangent. Or as many of you probably have said and probably will still say, sin, cos, and tan. If that's how you're going to remember it, that's how you're going to remember it. So, but just know that this is, when I say sine, I'm talking about this. When I say cosine, I'm talking about this. And when I say tangent, I'm talking about that one. All right. That is trigonometric ratios and just examples to show you how to set up these trigonometric ratios. I will see you again soon.